Yeah, hi everyone. I'm Konstantin. I'm head of product at Ververica. And yeah, I'm excited to talk to you a little bit about the Flink SQL side of Apache Flink, and also about what we've been doing at the product on the product side of Ververica. Basically, about 6 months ago, last Flink Forward, already virtual back then. I was talking a little bit, or looking a little bit ahead, what we've been, or what we are going to do on in the Ververica platform. And one of the things was an autopilot for Apache Flink. So basically, a service that would automatically configure, automatically scale your deployments, adjust to the load, and also keeping your resource utilization high. And well, as it comes, 2 months later, 3 months later, in August, we released Ververica Platform 2.3 with the first version of Ververica Platform Autopilot. So if you're using the platform, you can already let Autopilot scale your Flink applications horizontally, adjusting to the incoming load. And then there was another thing that I announced, and yes, those were the best screenshots that I actually found. I also announced what I called integrated streaming SQL platform. And to those of you who are following Ververica a little bit, it's not a big surprise that's what we are announcing today. So today we've released Ververica Platform 2.3 about an hour ago or so, with support for Flink SQL on the Ververica platform. And I want to take this basically as an opportunity to talk about Flink SQL more generally, and to give you an idea of what kind of use cases you can use Flink SQL for, also how you can, or show you a bit how you can use it on the Ververica platform. And yeah, that's what I'm going to do in the next roughly 30 minutes. First of all, just for those who are or who haven't used Flink SQL before, if I were to explain it to a Flink data stream API developer, if you will, I would just say it's a declarative API. Just as Stefan has said in the keynote, instead of writing your functional imperative code in the data stream API, you send a statement, you execute a SQL statement, and the planner, the optimizer, generate a job graph. The job graph is executed as a Flink job. Fair enough. Basically, to anyone else, the data scientist, the data warehousing engineer, the database administrator, or basically everyone who has some experience with traditional database systems, I would explain it a bit differently, and I would basically tell them Flink SQL is like materialized views on steroids. Like a materialized view maintenance engine in a traditional database, Flink SQL consumes input tables continuously and produces output tables continuously. The only a difference is that Flink SQL just has more features, it has higher performance and better consistency guarantees than what you usually get from a materialized maintenance engine in a traditional database or data warehouse. Another difference is that Flink does not store the tables itself. It always operates on the tables on external systems. So the input table is maybe stored in Kafka, the output table is maybe stored in an Elasticsearch index. And I would argue that with Flink SQL, you can actually reach quite a breadth of stream processing use cases, and maybe even majority of stream processing use cases can or could be solved with Flink SQL. The main use case areas or broad areas that we see most Flink SQL adoption right now are ETL and data pipelines, real-time analytics and CEP, and well, more generally, materialized view maintenance, where you want to offload the processing from an existing database or existing maybe mainframe system, and do the heavy computation in Flink, produce views for downstream services that they can query from some kind of serving layer. Could be, again, Kafka, could be Elasticsearch, depending on the nature of the views. But in this talk, I don't want to talk a lot about these like broad use case categories, but I want to show you some very concrete examples of things that you can do with Flink SQL to just kind of spark your imagination and to think about, or to make you think about, how could I use Flink SQL for my business, for my use case, or in my domain. And yeah, that already brings me to the demo. In contrast to what Holger said, it's not a live demo. I've pre-recorded it, but I'm going to talk you through it live. Didn't have the nerves. So let me switch to the video here. And yeah, it's quite, whoa, it already started automatically. Let me reset it. It's quite fast-paced, so bear with me. Yeah, here we go. So we're going to start in the Ververica platform UI. We're switching to the SQL editor, and we basically, we have a usual SQL editor. First thing that we need to do, since SQL always operates on tables, we need to create a table. And we're going to create a temporary table called people with 2 columns, a name, string type, and age, a tiny int. And now in the with section of the create table statement, we need to define the connector properties. So what is this table backed by? And here it's just a data gen table, which is a table that produces the data when it's queried just randomly. Just as a first example. So we have that temporary table here, and now we can query that table. Just a select statement, and we execute it. Okay, 10 rows, 10 people, random data. Fair enough. You get the idea of that editor. It's a SQL editor as you would imagine it. Now let's do actually something a bit more meaningful. So I have a Kafka topic with orders data, the typical TPCH example, JSON encoded. So I'm getting a template here for a Kafka table, name it orders. I'm copy pasting the schema here, and while I'm filling in all the properties, like the topic, the bootstrap servers, and so on, you can also have a look at the schema. Basically, what you would expect: a primary key, a customer reference, a total price, a timestamp, and a few more fields like a comment. Only need the group ID here, and now I'm basically done. I'm going to create a temporary table first just to try it out, and then later I'll store it in the catalog. So again, we can query that table. And well, now it's a streaming query, querying from Kafka, and we see the results coming in. Fair enough. So that table works apparently. So we're going to execute the create table statement. And now we have a Kafka table in the catalog. I can query it again. Still works. And what I want to do in this first application is typical data cleansing job. So I'm just going to transform that table that is JSON encoded into an Avro encoded table, and I'm going to do one very simple transformation on the way. And that transformation is changing the timestamp from a string format to a timestamp format that Flink actually understands for like time-based queries later on. So you could also imagine doing more things like dropping fields or dropping rows if certain mandatory fields are null, or they're doing arbitrary transformations here. So just going to fill in the format. And yeah, I'm not going to change the name. It's still the order time, just different type. Now, a few more fields. And we can execute that again. And again, it's this very similar output, just that the order time is a little bit differently displayed here because it's a different type. So now we want to insert that into a new table, clean orders. And let's execute that. Well, it doesn't work. There is no clean orders. So we first have to create that table. Again, Kafka, but this time Avro Confluent. Need to fill in all the properties again. Note that the table name and the schema, that's already filled in automatically because we already had that query in the editor when I created the template. So that's automatically done here. Yeah, and order time is a timestamp now. So the schema registry information, also the subject. And yeah, now I will also create a processing time field in case one of the consumers of that table needs that, and a watermark and watermark information for the order time. I mean, if you've maybe you've noticed, probably not, the records are out of order up to 15 seconds. So we will delay the watermark by 15 seconds so that we get correct results, even though this is out of order. Creating that table. So now we have a second table, and now we could actually execute that. I'm gonna quickly save that script, give it a meaningful name like cleansing orders from Avro to JSON, but actually it's the other way around. So it's JSON to Avro, and save that. And now if we run that, the platform tells us this requires a deployment. And a deployment is basically the like high level abstraction for a long-running service in the platform. And since this is a long-running continuous query, we need that. I've also enabled autopilot because it's new and we had some time. And now we are waiting for that deployment to spin up. A little bit of time lapse here, takes about a minute, I would say, spinning up a cluster, spinning up or shipping the dependencies and everything. Now we can go back to the editor and we can query that table again. So that is now in the background maintained, basically a materialized view on top of the raw orders, the clean orders. And again, after a few seconds, we get results in right from Kafka now. And well, now we have data with a timestamp and so on, so we can start doing some typical streaming SQL, like a tumbling window. So that is a window that is a fixed size, non-overlapping. I'm going to use 15 seconds here because, well, if I use an hour, we won't see any results during the keynote. Also need the window time in the output so that we can distinguish windows using this tumble row time built-in function. And yeah, now we can do arbitrary aggregations. So we can count orders, for example, or we can count distinct customers. And let's also do the total, like, order volume, total price of all orders. So once I spelled that out, we can execute that statement again. And again, we see live results coming in, 3 rows. And we can also have a look how does this job actually look like in the Flink UI. So this is what the optimizer, what the planner have made out of that SQL query. Sometimes quite useful to understand. Now let's also do something else in the data, in the like streaming analytics space, if you will. We can do some kind of running total. So let's get the order time, the price, and in addition, the sum of all orders up to the point in time that this order came in. I'm going to use an over window for that. Again, querying the clean orders. And the window W is basically the complete past sorted by order time. And now if we execute that, we'll basically do 2 things. It will sort the stream by order time, so no out of orderness anymore. And we will get the total price for each order and then the running total of all orders up to that timestamp, up to that second. Now I want to come to the next kind of main query that I want to show you, or main application. And if we look at the order stream again, we can see that there is this Latin language comment, 1 sentence. And what I want to analyze is how is the sentiment expressed in these comments changing over time. I need 2 user-defined functions for that, actually. and one user-defined function, one table function that is splitting up this comment into one word each, and one one scalar function that gives me the sentiment value for a word between -10 and 10. So I'm going to click on plus functions here and uploading my jar with my two user-defined functions. Actually, it has more user-defined functions, but I'm only going to use the sentiment function and the split into rows function. Creating those functions and back to the editor. And now we see we have two functions in our catalog. So that's nice. We can use them. And we'll start by splitting up the comment into words using this like lateral table join, if you will. Splitting the comment into words. You'll see what exactly this is doing in a second when we execute the statement. I'm going to choose the order time so that we still have the time information and the word. And if we execute this, well, we get the time. And we get one row per word in my comment. I'm going to create a temporary view for that because I want to use that table now in the rest of my script here. And well, a temporary view is basically just a named query. So instead of executing that query, I can also just query the temporary view. That's what I'm doing here. Same results. And yeah, what we wanted to do is get the average sentiment over time. So I'm going to use average built-in function, the sentiment user-defined function, and that's our average sentiment. Now we want to have that over time and not for the whole history. So again, I'm going to use a group window, this time a hop window. That is a sliding window, basically fixed length, but overlapping. And yeah, 10 seconds slide, 1 minute window length. So basically every 10 seconds, we will get one row with the average sentiment of the last minute. Again, we also need the window time in the output. Otherwise, we don't know what we see here. And we can execute that statement now with. We should see a lot of rows, a little bit of history to go through, but in essence, one row every 10 seconds. I'll leave it running for a minute or so. In the meantime, already creating a temporary view for that as well, because I need it in the rest of the script. And the first thing that I want to do is I want to publish that information again to Kafka so that other real-time consumers can use the sentiment information in their application. So inserting it into a new table, sentiment RT, that table doesn't exist yet. So again, we need to create it. I'm going to use Kafka with Afro confluent format. Again, table name, table schema have been pre-filled already. So only going to need topic again, bootstrap servers, so on and so forth. In the meantime, results are again are still coming in. Yeah, and for the real-time consumers, for the Flink SQL real-time consumers, I'm again going to add watermark information directly. The out of orderness should be pretty limited, but I'm just going to use 15 seconds again for convenience. But since the windows are ordered, there's maybe only a bit of out of orderness introduced by the round trip to Kafka. And also a processing time field, just in case someone needs it. All right, so we can execute that part. Now we have, yes, now we have the sentiment RT table. And besides the Kafka topic, I also want to publish it to Elasticsearch right away. Then we can also build a Keymana dashboard or so without any further application. And again, this needs a table. This time Elasticsearch 7 with JSON format, because there is no other format in for Elasticsearch. Fixing the table name here, it's actually sentiment. And for Elasticsearch, we only need the host and the index name. So that one is quicker. Right, executing that. Now we have an Elasticsearch table, and now we can submit this. But actually we cannot, because only a single insert query is supported per script. So we need to wrap the whole thing into a statement set. And a statement set that is the same as in the table API. It allows you to combine multiple insert into queries into one application or into one Flink job. They are holistically optimized. You can reuse intermediate results. So it's much more efficient than two jobs. And again, we're going to create a deployment for that. So that in the background, we now have a materialized view for this sentiment data. Again, this takes a minute until it's up and running. And back to the editor, and we can query that table now. And anyone else could too, of course. So results should come in after 10 seconds or so, and then every 10 seconds we'll see a new row coming in. So very much the analogy, I think, with materialized view maintenance for these kind of use cases, it fits very well. Now, we've seen two examples already. We've seen the cleansing orders, we've seen the sentiment analysis, and now I have two more scripts that I want to briefly skim over with you without going into every detail. The first one is sentiment drops, and it takes this sentiment data that we just created, and it's looking for periods of time where the sentiment goes down 2 or more windows in a row. And we're using the match recognize clause for that. Well, we're consuming the whole table from the beginning, and we're using the match recognize class for it. This is basically, or it is a rather new addition to the SQL standard that allows you to do pattern matching on tables. And in combination with Flink's dynamic tables, this actually gives you kind of real-time complex event processing capabilities in pure SQL. And what we are looking in for here is an event A that can be any event, then at least 2 events where the sentiment goes down, and then 1 event where the sentiment goes up again. And if we execute that, we actually see this happens quite a lot, sometimes for 20 seconds, sometimes for 30 seconds, and sometimes sentiment also drops for 50 or 60 seconds. And you can see, you can also get a little bit more details about what kind of event that was. So that's match recognize. The other example that I want to show you actually needs some tables from Hive. And Flink and Ververica platform ship with the so-called Hive catalog that allows you to import the metadata from the Hive meta store directly into Flink without creating tables manually for each of the Hive tables that you already have. It's called the external catalog, and there are a couple of more besides Hive under development already. So I'm going to create that catalog, and voila, we have a view on our Hive data warehouse. Now we go back and we are looking at the top segments and region. And what that is doing is it's taking the order stream that we've worked with, and it's joining 3 tables from Hive to each order to find the customer segment and the region name for each of the orders. And then we find the top segment, the top region, and write that information back into Hive. So more specifically, the first query is this lookup join. Yeah, that one. And so basically 3 ways: first the customer, then the nation, and then the region. And yeah, it takes a while until this is actually running, because like loading all the Hive classes and so on takes a bit of time. Then in the next 2 queries, I'm aggregating, or I'm counting orders per region and per segment for 15 seconds again, because I want to see some results. And then I'm doing a self join for each of these views to find the top segment and the top region, or the regions and the segments that attain the maximum count. And once I have those views, I can write them into Hive again, and I'm using a statement set for that. And yeah, writing directly into the top segments and top regions table in Hive, with some additional dynamic table options that don't come from the Hive Metastore. And yeah, dynamic partitioning, partitioning by day and by hour here. And yeah, Flink will automatically finish the petitions, publish the petitions in the Metastore, so that downstream consumers on the Hive side see when petitions are finished. That brings me to the end of my demo. I realized that, or as I said, I think it was quite fast paced. I hope you get an idea of what you can do with Flink SQL. But also let me go back to the slides first of all, and let me recap a bit. In particular, let me explain a little bit what we've added on top of Flink SQL in the platform. So of course, there's the SQL editor. You have seen that. It gives you things like auto-completion, continuous validation, of course, the preview queries in the browser, which I think are very powerful for developing these scripts, and also the schema explorer. And of course, we're already adding more things as well, not as I speak, but yeah, in the upcoming days. Then there is catalog and dependency management in the platform. So you don't need to worry about connected dependencies. Those are already baked in. You can just upload your user-defined functions. We scan the jars, we find the UDFs, we register them for you in the catalog. And all of that is per namespace in the platform. So that's not per individual user. You can share dependencies. You can share the catalog with your team. Then you get an operational framework for Flink SQL. So once you have a query that you want to deploy, you right from the editor, you can create a continuous or a long-running deployment from that, and you can manage it like any other deployment in the platform. So same lifecycle management, auto-scaling, monitoring capabilities that you already have for jar deployments in the platform. And then there's one more thing that I actually didn't show, and that is notebook support. So today we've also released Jupyter VVP 0.1, which is a Jupyter extension for Flink SQL based on Ververica platform. It is, well, it's an extension to the IPython 3 kernel. Basically just marks cells as Flink SQL cells, and then you can execute Flink SQL statements right from your Jupyter notebook. It's open source under Apache 2 license, independently released from the platform. It has not yet reached feature parity with the editor. In particular, you cannot do these preview queries yet. But since we release it independently, we can iterate quickly on that. Now I'm back, I think. So we can, since we independently release that, we can add that functionality quite quickly now. Right. So I hope that kind of sparked your interest, and you can't wait to try it out. If you want to do that, the requirements or the prerequisites are still the same as before. So you need a Kubernetes cluster, and you need some kind of blob storage provider. That can be S3, it can be MinIO, it can be HDFS, Azure Blob Storage, something like that. And that's basically it, because everything that I've shown you today, except the statement sets, are available in Community Edition, free of charge, free for commercial use, unlimited number of deployments, unlimited size of deployments. So basically, you get everything that I've shown you, without even giving us your name. you'll find the Getting Started guide in our documentation. If you want to start right away, just add our Helm repository and install the platform via Helm. And yeah, that's basically it. I want to conclude my presentation or my my talk here again with a look ahead, but this time not so much focusing on the platform, but on Flink SQL in general, and want to briefly go over some of the developments that are currently ongoing in the community and that we can expect to come into 1.12 or slightly after. So first of all, there's Flip 107, which adds metadata handling in the SQL connectors. The most important application of that is that you can read Kafka keys and timestamp information from records, and you can write Kafka key and timestamp information. Right now, you can only read the value. Then there is a Confluent Schema registry. So basically what we have seen for Hive, just for the Confluent Schema registry. You don't need to register your tables anymore if you already have that information in the Confluent Schema registry. Then there are temporal table joins on changelog streams. So right now in Flink, you can do temporal table joins, but only on append streams with a table function. So you need to register something outside of SQL, if you will. With Flip 132, you can do that in the platform, not in the platform, in pure SQL, also in the platform, just with a for system time as of join. And you can do it on changelog streams, not only on append streams. And last but not least, Flip 145 with the little bit abstract name windowing table valued functions. It's basically a new way to do windowing in SQL. So instead of using group by tumbled, group by hop, you kind of window the whole table, which gives you your original table with all its columns plus 2 more columns, a window start and a window end. And we hope that's on the one hand easier to understand for someone coming from batch SQL, and on the other hand, it makes it very easy to integrate Flink or windowing with any other SQL command. So, for example, window joins are very easy like that because you have the windowing information right as table columns to use. Yeah. So these are 3 topics. There are a couple more topics in the pipeline. But I think those are the most immediate ones on the Flink SQL side. On the platform side, we'll try to keep up with the fast advancement on the community side, and yeah, we're just going to try to make shed the best light on Flink and make it as easy, as scalable, as manageable to use as possible. And yeah, I think we have a packed backlog of things to do there, and then we'll see what we have come up with at the next Flink Forward. If you are interested to learn a little bit more about these topics, there is a talk today by my colleague Fabian Paul on autopilot. There are 2 talks about Flink SQL in the platform by Fabian Huske and Nico tomorrow, and there's always an Ask Me Anything about Ververica platform at the end of the day at the Ververica booth. That you can also join. That brings me to the end. I hope you've enjoyed that talk. I hope I didn't lose you somewhere around the demo, and enjoy the rest of the conference, and enjoy your evening, enjoy your morning, enjoy your day.